So it will pop up the calibrate window for you. Um, is there anyone has successfully opened the data in Snap?
Still haven't received the authorization to access the data.
Okay,
I have
then yeah.
shared it with a lot many people. I believe at least I've shared it with 10 people already with right to edit. I believe those must be able to access it.
Yeah, just keep trying that, and meanwhile, I'll just keep demoing everything. So yeah, so again, go to the radar option, go to radiometric option and calibrate option. So once you open the calibrate pop-up window, it will ask you for your source file, which is the input data, which we have just imported. So this will remain the same. And then the target product. So after calibration, the image has to be saved. So I'm going to save it in my folder. I'm going to save this in data too. Okay, I've selected my folder. It has automatically renamed the file, the target file with calibration extension. So if you go to the processing parameter, we want to process both pH and VV polarization and just select uh, run. Oops, sorry. It is a big image, so it is taking a little bit of time. And so the catch is that if you have to process for the entire tile, then you must go like as I demonstrated. But if you want to do it for a smaller area, you can just subset your image. So once you calibrate, your intensity and amplitude bands are going to be replaced by sigma VV. So sigma is the backscatter coefficient. So what happened in calibration is it just convert the digital number into backscatter coefficient, which I already mentioned is the backscatter coefficient is the data that we use for analysis. So your all the images has to be converted into backscatter coefficient. So if I show you this and this, there is a significant yeah. So for example, if you want to just look at both the images at the same time, you can opt for like horizontal tiling. So this is the image before calibration and this is the image after calibration. You can just like organize it the way you want. And again, if you click on this, it will get back to the single image window. So after calibration, we will perform the thermal noise reduction. So SAR data has a bit of sensor noise from the thermal activities of the sensor because there is a lot of ionization going on. So to correct that noise, we will perform the thermal noise reduction on our calibrated image. But before that, yeah, just let's apply the thermal correction. Just go to the radar and go to the radiometric option and go to S1 thermal noise removal. Here you can see that it has taken it has already, your input file should be your calibrated file because everything is going to lined up one by one. Just be aware that you have not selected the primary product that we have uploaded. You have to select the calibrated image, right? So which Snap automatically does for you, but in case you have to keep that in mind. So your again, you have to give your target directory where you want to save your product, and the name is automatically given here. It is calibrated and then thermal noise applied. Just go to the processing parameters. You make sure that remove thermal noise checkbox is you have checked this, and then run. Do you have do you have any question so far?
Now it's clear.
Okay, the processing has been completed. You can just close it. Just close all the images. Just open the bands again. Okay, you can see the difference between after removal of uh, the thermal noise. So if you click this option here, it is going to toggle both the images for you. So it's going to synchronize uh, your viewing. So you can see that it has like thermal noise reduction has like made it like more like more clear, visibly clear. So that's what the removal of thermal noise does to the image. I'll just go back to this and turn off this. Okay, so now we have an image which is calibrated and which is thermal noise removed. The next thing we are going to do is apply speckle filter options. This is also one of the most important steps that we should not miss. We go to so speckle. Let me first tell you what a speckle filtering is. So what happens is that radar backscatter gets reflected twice from the urban areas from the building. So it has a grainy texture. You can see that it's like very grainy texture. So the speckle filtering helps removing these uh, speckle noise from the image. And to do that, we'll go to the again, we will go to the radar option. We will go to the speckle filtering option and then single product speckle filter. And when the window pops up, make sure the input image is your calibrated and thermal noise removed image. Like if it doesn't show, you can just like select uh, from this option, and then your target folder and your target image. And then in the processing parameters, there are a lot of options for speckle filters. There is like Lee Sigma, Refine Lee, Gamma Map, and also the window sizes. You have options in window sizes as well. We usually use 5 by 5 or 7 by 7 window and Lee Sigma. So I'm just doing it on the default uh, and then just click run. Just let me know if I have to repeat a step, or if you guys have missed some step, or if you don't understand why we are performing a particular uh, process.
Please excuse me, but I have a question.
Yeah.
Do all images taken from the satellites have to get all these treatments, or it's a sequence of treatment for each data or each type of data that we are going to use?
No, this is particularly for Sentinel-1 SAR data. Anyway, you have to process all this SAR data from radar set, or any other radar satellite. You have to go through the pre-processing steps.
And for the second Sentinel?
For Sentinel-2, no. This processing is only for the SAR data, for the radar data.
For the radar to get okay.
Yeah. Because we don't have speckle noise in spectral optical data. And you don't you don't have backscatter coefficient in optical data. It's just like the DN value of the bands. So yeah, you can already see that how different radar data is from the optical data.
Another question, please. In this image, what does 1 pixel represents as data for the radar? 1 pixel in this image, each pixel.
Sorry, what's the question?
In this image, the
Yes.
images we get from the radar, each it's pixels. Yes.
Yes, it's pixelated data. You can see pixels.
Yes. Each pixels is formed represents what, in fact?
Each
Is
pixel
it
is
one
exactly
value?
yeah, 1 DN value. Yeah.
And this value is computed by the satellite and sent.
Yes, it's computed by the satellite. That's what the satellite it captures the incoming reflected EM wave. So here you can see that this area is particularly bright, right? And the other data, like in the surrounding areas, are a bit darker. Can anyone tell me why this area is brighter and the rest of the area is darker? Because I already mentioned that, like only 10 minutes ago, the backscatter coefficient, the backscattering process. So if you remember, I mentioned that backscattering coefficient is very high in urban areas because of the double backscattering. So all this area is actually the Delhi NCR region, and it's bright because this is a very high density urban area. So you can see that it is like very bright. And then you can see that there is this particular line which is very dark. Any guesses on this one?
River.
River. It's a river.
Yes, yeah, that's correct. Because you can see through the pattern that it's a river. So the water bodies in these radar data will always be black. Not black. It's very dark. Because what happens is that the water body surface completely just reflect uh, the EM rays, and it never goes back to the sensor. So that is why it's just the water body will always appear very dark. And which is why we mainly use radar data for oil spilling analysis. Uh, I guess you are aware about the oil spilling events that keep on happening in the oceans. So what happened is that the radar data for the oil spilled area is particularly even darker than the water areas. So you segregate the oil spill area from the water, from the just the water areas. So that's how you do it. Okay, now we have the speckle filtered file. So if I just click on, okay, now just compare. Can you see like the changes? It has significantly like improved. This image is like very grainy, right? And this is a bit smoother. Okay, perception. It's less grainy, and this one is like very grainy. So that's what the speckle filter does for you. Okay, now we'll go to the next process, which is geometric corrections, because this image is not georeferenced. So now we will perform the terrain correction on the radar dataset, the SAR dataset. Uh, so you just again go to the radar option, click on radar option, and then click on the geometric option, and then terrain correction, and then just go to range Doppler terrain correction. This will open This will open a pop-up window for you. So you just correct your calibrated thermal noise reduction and speckle filtered image. You just select this one, and then you select your target image name and then your target folder, and then go to the processing parameters. So here we are processing both the bands, and here you have the option to choose like which SRTM, like how much details you need in your corrected image. So you have options for SRTM 3 second, 1 second grid. So we'll choose like the 3 second. You can also click on the external DEM. So if you have any external DEM, you can just browse from here. I don't have it now, but if you guys have, then you just just go to the destination folder, select your DEM file. Otherwise, it will just automatically auto download for you. So you just select the 3 second uh, data for the SRTM 30-meter data. And then if you want to create an incidence angle, sometimes you need incidence angle for analysis or for calculating latitude, longitude, you can just select all these parameters. So yeah, so that's about it. Just select the DEM that you want to use and just click run. All right, this writing finished. Please try to do it now because then, we will be able to troubleshoot if there are any errors or you're not able to run a particular process. If you have received the link, if you can download it, just do it now, uh, so that you can just practice it now.
Also, just to give you a heads up, Pooja, you have 30 more
Yeah.
minutes to wind up everything.
Oh no, just okay. Oh,
Yeah, we have touched 7, so the session is timed till 7:30, and it's quite late for the participants as well for the long day.
yeah, it's
In
true.
between there's issue, and then that sort of dragged it, but just wanted you to know.
Well, this is the last step of the Sentinel-1 pre-processing. So,
Okay, all right,
and this is the main part.
okay.
And all these steps that I'm just mentioning are available. Papa might have shared. There is a manual. This entire manual, so whatever we are showing to you is already there in that manual. So you can just practice it on your own once you have downloaded the data. In my previous session, I already showed you how to download the data from the Copernicus website. In case you don't want to work on this data because this data is from India, in case you want to work on your study side, then just go to the Copernicus Open Access Hub and just all the other options. Yeah, you can download data from here. I'm just putting the link into the chat option. So just bookmark it if you want to use Sentinel-1 data. Okay, the processing has been finished. So we have geometrically corrected our data. Okay, now you can see that it is a bit tilted because it's now georeferenced. This is non-georeference and this is georeference data. So this was the last step of the Sentinel-1 data pre-processing. Just let me know if you have any questions. Uh, you can also visualize your image in RGB bands. So just select your image, double click, and then open RGB image like red, green, blue bands. So this will open. Uh, just so there is a band combination for a better viewing. Um, so in the red option, we'll select the VH band. In green, we will select the VV band. And in the blue, we'll just delete this. Oh, sorry, I did it a bit quickly. I'll show you. Just replace VH in red, VV in green, and for the blue, just go to these three dots extension, and then just remove the earlier expression, and then just VH, and just select this minus operator. Sorry, it's not minus, it's plus. VH plus sigma VV. You just have to add these two and then click OK and then click OK. So yeah, now you can just clearly see the urban areas, you have patches of urban areas. So there are like other options as well. You can just play around with like all these options and just figure out which band combination gives you the best visualization. Uh, okay, now I will show you how to subset your image. Um, just sorry, this is, I'll just remove this one. Yes, open this one. Right. So, for example, if you only want to perform analysis on a very small image, then you can just do the subsetting of an image. Uh, just click on this. Yeah, just go to the raster option. First, select your file, go to the raster option, and then select subset. So here, just for example, I just want to subset the urban areas, the NCR region. So just this bounding box will already be there. Just select that. You can also select if you want only the VH band, you can also select that. Uh, and then just click OK, and it will produce a subset file for you. Okay, so this is the subset file. Another thing is that sometimes we directly use the backscatter coefficient values. Sometimes we express it in the decibels. So to make the decibel band, just click on the band that you want to convert into decibels and right click and just click this option linear to dB. So it will make a virtual band for you, which you can already save as the actual band. So we have converted for VV. Now we will convert for VH. And when you finally save this image, these bands will automatically be saved. So yeah, don't miss this step if you want your analysis to be performed in the dB values. Uh, oh yeah, this analysis tab is for analyzing your image. You can just create a scatter plot to see how your values, the value ranges, and how they are distributed. So for this, just select the band that you want to see your values for.
I think you have to select also in the Y axis. No?
Um, no, it should, yeah. Oops. Creating Let me just save this product. All the images pre-processing steps that you have performed, just save them in a folder. Let's close this. Okay, I'll just again open Snap. Snap is froze. Okay, that's fine. Let's open image. I've selected this band. Let's select this band. Go to analysis. Set a plot. What is this? Yeah, I don't know why it is showing just straight line instead of a scatter plot. Same is happening with the histogram. Let's just select another file, the non-subset file. Wait.
Um, Pooja, just a reminder, we have last 15 minutes.
Oh, okay. Yeah, so we have basically covered the processing part. I'll just, since we are only left with 15 minutes, I'll quickly show you the Sentinel-2 dataset. Um, just remove this one. Again, same process for the Sentinel-2 data. Just go to the Sentinel-2 image, wherever you have saved Sentinel-2 image. So Sentinel-2B, it's the resampled image. Loading the Sentinel-2 image. So once you successfully upload your image, just go to the bands. These are the different bands. So 11 and 12 is your spill band. One is your B1 is your cloud mask cirrus band. Uh, uh, and B2, 3 are your blue green band, red band. 8 is your infrared band. So just to show this one band, if you want to see this in RGB, true color composite, just click this image, right click, go to the RGB, and uh, your natural color bands are already selected, and just click OK. So yeah, this is your image in natural colors. So this is Sentinel-2 image, which is the optical data. Here you can clearly see agriculture lands, river portion. All these white portion are river banks, and even the urban areas are like very clearly visible. Uh, so it can also be subset in the same way we subset Sentinel-1 data. You just select the image, go to the raster and click subset. So just select like whatever portion you want to perform for, just select that from here from the bonding box and it will subset it for you. You can also select like band wise. You don't want on the bands, you want only particular bands. So just click on the bands that you want in your final destination file. So that will do it for you. You can also do a masking. So to like on the basis of a shape file, you want to extract some your study area. So you just click it and go to file, import vector data, ISRI shape file. Uh, I will just upload the IRI file. So I'll go to Kusa shapefile. Any shapefile that you have, just click on that shapefile, click open. And it has now loaded the shapefile on my raster dataset. So you can import vector files on your raster dataset. So once it is loaded on your raster file, you can just mask it, but you just cannot mask it without resampling. So you have to first resample your data. You can do subsetting without resampling all your bands. That does not demand resampling, but to mask your original image with your study area, you need to do resampling. So for resampling, you can just go to raster data set and to the raster option, uh, and here's resample. Go to the geometric and then go to resampling options. So here is your input data set. This is your destination port. Just click on this. Otherwise, it will not. It will only save it as a temporary file. So just click on this and just go to your destination folder, and then go to resampling parameters. So just be careful that here your reference band for which you want this, your reference band is the one that have the spatial resolution for the rest of the bands that you want. Um, so we don't want B1 because that's a different resolution. For example, you want all your bands to be resampled to 10 meters, then you select B2, B3, or B4 because all these bands are in the 10-meter resolution. So just click B2 and just click run, and it will resample the image for you. Let's see how much time. Yeah, it's taking a bit of time, so I'll cancel it. So once you have resampled your image, you can actually you can now mask it. So go to the raster, go to mask option, go to the land/C mask option. See, this is showing because it's not a resampled file. So I'll open the resampled file that I already have. This is resampled data, so I'll open it. I guess it wasn't saved. Yeah, it wasn't saved. Otherwise, it had like images. Anyway, once you resample it, you can go to the raster, go to the mask, Lancy, and then it will show you options for masks. If we have time. Yeah, it will show you this pop-up window where you have your input product, input resampled image, and your output image. And just go to the processing parameters. You have all these bands selected. Just use this option, vector, sorry, use vector as mask, and because it is already loaded on the resample image, it will mask it for you. So that's about the Sentinel-2 data sets. How much time are we left with?
Around
Five
five,
more.
6.
Yeah.
Okay, so I guess we'll keep that for questioning if you have any questions. The session was just about the basic info on the Snap, different tools in Snap. I showed you the majority of the raster tools. You can use optical for creating NDVI, a variety of spectral indices. There are a lot more other options here. So if you want to create an NDVI map, you just go to the optical, thematic land processing, and vegetation indices. There is an NDVI processor. So if you click it, it has already in your input image, output image named as NDVI, and then go to the processing parameters because you use infrared band and red band for calculating NDVI. It has already checked that. You just have to click run. You can run it in the default values and it will create the NDVI map for you. So
We do have one hand.
likewise, yeah.
We can quickly take one or two questions because I also don't want to stretch it any further than what we have. So yes, Mr. Nakib, please go.
Hello, madam. I'm very thankful to Pooja Singh, madam. Just I want to know very short question. For example, I want to go to the agriculture field. There is no data, no survey, no anything. Just I want to know about the vegetation data in water resources. How much deep the water in the specific area? Is it possible to find by this GIS?
How deep the water is.
Yeah.
Since radar data only penetrates a few centimeters, I Devasis sir, depth of oceans.
Yeah, I could not get Nakibullah. You were saying about some of the ponds that the deep, how deep it is.
Sir, I asked that, for example, you better know the Afghanistan situation. There is no data, no survey, the previous wars like this. For example, I get the project, okay? In I want to know about the specific area. There is no data, no survey. Just it is my first time to visit the field and understand how much the water depths in the specific area and the vegetation. For example, 2 3 years before, right now, like this. It is possible to understand and recognize this.
Okay, so I think
Indian
that you are
does
Pooja, I
he
think
mean like
he is referring to
Indonesian areas,
he is
indented
referring to
areas?
the Afghanistan, the ground level depth. I think so. Is it true?
Pardon?
You are referring to the groundwater level depth of groundwater.
Just it's
Which
like
water you are
groundwater
talking?
for agriculture, for agriculture purpose. Yes.
No, which water you are talking about? I could not get you.
What
For
landscape it is?
agriculture
Is it
purpose.
like for agriculture process? Yeah, you can.
Agriculture purpose. I want to know. See, I want to understand in this specific area how much water is available to cultivate tomatoes or other vegetables like this.
Yeah, that means you are referring to the groundwater only, because if there is no
Yeah,
surface
yeah, yeah,
water, it's only the groundwater. So for the groundwater,
yeah,
the hydrology and geology, these two are combining. So remote sensing is not all to give you
Yeah.
everything. It can only send about some information on the landforms and some of the vegetations which are there, and you have to correlate that. So definitely you need to have a ground truth. Otherwise, it's not possible. Only if you can get some ground truth points, then you can use the what is called the reservoir, the groundwater formation. That's called hydrology, groundwater hydrology. So there, the remote sensing, you can use it as an input, because you must know that the remote sensing, as Pooja said, that even if you are using the microwave, it will only penetrate a few millimeter, maybe 1 centimeter or a little bit more than that. So that is not enough. So whatever the
yeah,
surface informations you have to use it with other data. Like say you have to have a survey, you have to have some sort of groundwater, some sort of ground truth, and then only you can interpret. It is not the remote sensing by which you know that there is a groundwater depth is shallow or it's deep.
Yes, sir. Most of the
Okay,
remote
sir.
sensing data
Thank you.
sets are for the surface parameters. because
Okay, so you must understand the limitations of remote sensing data. It is a very
Okay.
it's a huge data. It's a very good information, but it has got also limitations.
Okay. Okay. Thank you.
So the Bashish, can we call it a day or are
I
we?
think so. I think so because now I think that
Fresh?
everybody is now so
Yeah.
exhausted and slowly the presence is also going down.
Yeah, it's dipping. I
Few
can
minutes back
see
it
it.
was 23, now it's 20. Okay, so I still I really congratulate all of you who have stayed so long. At least the
Yes.
20 or 18 or 17 people whosoever has stayed back. So I congratulate, or rather I can take liberty that because Pooja has been working with me for quite a long time.